All right, here we go. We're going to have a lesson on fiscal policy for all of you who missed school because of the snow. I hope you enjoyed the snow, but your homework's still due. So you need to listen to this and come ready with all your problems set, ready to go. So the analogy for the economy is it's like a car. It can go too fast. That would be like an inflationary gap, or running too hot, right? And then too slow would be a recessionary gap, and something needs to be done, whereas full employment would be at like 70 miles per hour. The government's job in this analogy is either brake or gas, depending on what's needed. So if we're running overheated, maybe they need to put on the brake, or if they're in a recession, maybe they need to put on the gas. So how does the government do that? They do it through two different toolboxes. So in the cartoon, you see the economy is leaking and somebody's coming along trying to fix it. They got two toolboxes: monetary policy there on the left, fiscal policy on the right. We'll do monetary policy after Christmas break. But we're talking about fiscal policy, which are actions by Congress to stabilize the economy. So what are those actions that they can take? Let's focus on them. Spending and taxes. So you have two types of fiscal policy with spending and taxes. You have discretionary fiscal policy and non-discretionary. Non-discretionary there on the bottom is automatic stabilizers. So these are things that don't need to be passed every year. They're already there to stabilize the economy. So whether it's overheating or usually it's a recession. So in a recession, unemployment and welfare and minimum wage all are automatic stabilizers, automatically in the law, permanent spending changes to help consumers and citizens. Discretionary fiscal policy has to be passed by Congress. So it's a new bill that is designed to change aggregate demand through government spending or taxation. Okay, so in a recession, Congress might pass a bill to increase spending. There are some problems with this. It takes some time. There's bureaucracy, as we know, between Democrats and Republicans to be able to pass bills, but that's what it's intended for, to change aggregate demand. Looking at discretionary, so these are two categories under discretionary fiscal policy. So you got the brake and the gas, back to our car analogy. So if you have an inflationary gap, you want to decrease GDP. So visualize in your mind inflationary gap. We're to the right of the long run aggregate supply curve. We've got inflation. Congress is worried about that inflation, so maybe they want to decrease GDP, put the brake on. So they can do that by decreasing government spending. So GDP, right, aggregate demand, is C plus I plus G plus X plus N. So they take that G category, government spending, and they decrease. Or maybe they increase taxes. What would an increase in tax do? Good. Hopefully you got the answer. It's going to decrease consumer spending or decrease business investment. And then we have a combination platter of the two, but we mostly will pick one or the other. Expansionary fiscal policy, the gas, when we have a recession or a recessionary gap, we need to increase GDP and reduce unemployment, close that gap. So they can increase government spending, build roads or spend money on schools or the military or whatever. Or they can decrease taxes on consumers so consumers have more money to spend, and that can increase AD as well. Or a combination platter, okay? So what we're trying to figure out is, let's say we're in a recessionary gap, like how are we going to actually figure out how much the government should spend? How do they do that? Okay, so looking at this, what type of gap do we have and what type of policy is best? Okay, so obviously we have a recessionary gap. Our meeting point there is to the left of the long run aggregate supply curve. So let's say the government spends, how much should they spend? Well, it looks like they should spend $100 billion because there's a $100 billion gap, right, between 400 and 500. But they really shouldn't spend $100 billion. Because if they spend $100 billion, it would look like this. Now, why is that? Why would it go all the way over there? Well, think about it. The velocity of money, right? So they spend $100 billion. So say they build $100 billion worth of roads. Well, they're hiring all these firms and paying them. Now they have workers who now have more money to spend, and all of a sudden we're boosting our AD way past the long run. Okay? So they don't actually have to spend $100 billion. And we know that because of the multiplier effect. So here's an example. Why do cities want Super Bowl in their stadium? So we know over the next 5-6 years, all the cities that have the Super Bowl, they bid billions of dollars to have it. Why do they do that? Well, if they do it, they know that an initial change in spending, so the money they spend to get it there, will set off a spending chain that totally helps their city out. All the hotels, all the restaurants, all the Uber drivers and cab drivers and subway systems and all kinds of things like tourist locations, right? All that will be magnifying spending. Okay, a simpler example. Bobby spends $100 on Jason's product, so that's a $100 change in spending. Jason now has more income, buys $100 of Nancy's product. Nancy has more income. She buys $100 of Tiffany's product. We have an increase in $300 in consumer spending from an initial increase of $100. That's the multiplier effect. Okay, so we have two types of multiplier effect. We have a spending multiplier and we have a tax multiplier. We're going to look at both. We're going to start with spending. Okay, so the government spends $5 million. Is aggregate demand going to increase by the same amount? No, we know this, right? Consumers spend money and they spend more and more, and that's going to increase AD more than that. But by how much? Well, it depends on how much they save and how much they spend. If consumers in general in our economy save a lot, spending will only increase by a little bit, and thus AD will only increase a little bit. But if they save just a little and they spend a lot, then AD will increase a lot. So how do we know this? Well, we have a term called marginal propensity to consume, MPC. It's simple. It's how much people consume rather than save when they have a change in income. Okay, and it's usually in a decimal. It says fraction, but go with decimal. Okay, between 0 and 1. So change in consumption over change in income. So you got $100 right there, example number 1. You spent 50. So put 50 on top of 100. Reduce that to a decimal. Right? 0.5. So MPC is 0.5. It's going to be between 0 and 1. So 80, number 2. You received 100 and spent 80. 80 over 100. 0.8. MPC is 0.8. How about 100 over 100? MPC is 1. Okay? It's that simple. So you need to know this term, marginal propensity to consume, MPC. There's also a marginal propensity to save, MPS. How much people save rather than consume when there's a change in income. So if you got $100, example number 1, and save 50, look at the equation. MPS equals change in savings over income. 50 over 100, so your MPS is 0.5. If you received 100, your MPC is 0.7. What's your MPS? Well, you don't know this yet, but I bet you can guess that if you're either saving or consuming, your MPS in this example will be 0.3. The other way you could do it is if you know MPC is 0.7, you know that means they spent 70 out of that 100. So you have 30 in savings, so 30 over 100 is 0.3 as well. But, like I said, they're going to equal 1. So MPS equals 1 minus MPC. Why is this true? When you get money, you either save it or consume it. So you might save it and invest it later, or you might spend it now. But that's what people do with money, okay? It's going to equal 1. So let's figure out how much spending is multiplied. Assume MPC is 0.5 for everybody. So everybody in this society has a 0.5 MPC. Super Bowl comes to town. There's an increase of $100 in Ashley's restaurant. So she's got $100. How much is she going to spend? She's going to spend 50 because MPC is 0.5, right? So she spends 50 at Carl's Salon. She saves the other 50. Carl with a K now has $50 more income. He spends 25 because his MPC is 0.5. So he has $50 more income. He's only spending half, saving half, and he's spending it at Dan's fruit stand. Dan has 25 more income. So what's his MPC? 0.5. What's he going to spend? $12.50. So it goes on and so forth until every penny is spent or saved. So we get an equation where we use this multiplier, where if we want to figure out how much GDP changes, so go back to that original equation or that original graph of the 100 billion, the multiplier times initial change in spending equals that total change in GDP. Well, how do we find the multiplier? Here's the spending multiplier. It's 1 over MPS, or, as you know, MPS also equals 1 minus MPC, so it's 1 over 1 minus MPC. So if the MPC is 0.5, how much is the multiplier? So 1 over 0.5 equals 2, right? Good. Look at the first example. If the multiplier is 4, how much will an initial increase of $5 in government spending increase GDP? Look at that equation below and plug stuff in. So plug 4 into the multiplier, plug $5 into the government spending initial change, and that's an easy equation. You get a $20 change in GDP. How much will a decrease of $3 in spending decrease GDP? Assuming multiplier is still 4. Put the multiplier 4, initial change, you need to put negative 3 because it's a decrease. So your total change will be negative 12. Awesome. Okay, so let's practice a little bit. So number 1, number 2, number 3, number 4, go ahead and practice now. Okay, if you're not ready, go ahead and pause it and practice it on your own. If you're ready, let's do it together. So 1 over 0.9, nope. It's got to be 1 over 0.1 because you got to do 1 minus 0.9 for the multiplier. So 1 over 0.1 is 10, so the multiplier is 10. Number 2, 1 over 0.2 because it's 1 minus 0.8, right? So 1 over 0.2, multiplier is 5. Number 3, if the MPC is 0.5, consumption increased 2 million, how much will GDP increase? Well, we have to figure out the multiplier first. So 1 over 0.5, because 0.5 and 0.5, MPC and MPS are going to be the same. 1 over 0.5 is 2. 2 times 2 is 4 million. That's how much GDP increases. What if the MPC is 0? People save all of it. If people save all of it, then the multiplier is going to be 1. So when they increase investment by 2 million, that's the only increase we're going to have. 2 million times 1 equals a $2 million increase. Notice that as we go through, as the marginal propensity to consume falls, the multiplier effect is less, which should make sense. As people consume less, the multiplier is less. Let's do some practice. Okay, looking at this problem here, you've got a gap here on the left. Answer those 4 questions using that MPC of 0.8. Go ahead and pause and practice. All right, hopefully you got all the answers ready to go. So we see that yellow dot on the left. That is a recessionary gap because it's the left of the LRAS, which means we need expansionary fiscal policy, which means there are 2 options. We're ignoring the combo platter. You can increase government spending or decrease taxes. Okay, so let's go with increased government spending. How much do we need to close the gap? So the gap is 500 billion. So we know that's to the left side of the equation. So 500 equals multiplier times initial change. We're trying to figure out the initial change. We could figure out the multiplier because we have MPC of 0.8. So 1 over 0.2, because it's always 1 over MPS. So 1 over 0.2 equals 5, right? So 5 times X equals 500 billion. So we increase spending by 100 billion. Let's do the next one. Okay, so you've got a yellow dot to the right of the LRAS, so figure out what that gap is. Answer those 4 questions with an MPC of 0.5. Pause now. Okay, type of gap there to the right is an inflationary gap, which means you need, contractionary fiscal policy. You need to press the brake, which means you're either decreasing government spending or increasing taxes, ignoring the combo platter. So we want to close the gap by negative 20. So see the difference between 80 and 100. So negative 20. MPC is 0.5, so MPS is 0.5. So 1 over 0.5 is 2. So X times 2 equals negative 20. So we need to decrease spending by 10 billion. Very good. All right. But what about taxing? Okay, so expansionary policy of cutting taxes has a different multiplier. And the reason for this is if you cut taxes, okay, so if look at this example, MPC is 0.75, multiplier is 4, right? That's spending multiplier. If the government cuts taxes by $4 million, so all of a sudden we as citizens have $4 million. But when we get $4 million, that's a change in income, isn't it? So when we have that change in income, are we going to save some of it and spend some of it? Absolutely, because it's 0.75. We actually don't spend all 4 million. So it can't be 4 million times 4. It can't be the spending multiplier. It's got to be less. As you see with the tax cut, consumers are going to save $1 million of that and spend $3 million of that for. So the $3 million is the amount magnified in the economy. So it actually changes consumer spending by $12 million. So what you could see is an increase in government spending actually has a bigger effect than taxes. Government spending would increase AD by 16 million, but taxes would only increase it by 12 million. Because when you cut taxes, what you're doing is handing people money, new income. But when people have new income, they don't spend all of it. They save part of it. So it can't have the same effect. Whereas if you're doing government spending, the government's just taking all this money and spending it in the economy. It's automatically spent. There's no new income for people at that point that they have to then take into account saving or spending. So the tax multiplier is a little bit different. It's going to be MPC over MPS. So if the MPC is 0.75, what's the tax multiplier? So 0.75 over 0.25, so it equals 3, which is what we did in the last example. So if the spending multiplier is 4, the tax multiplier is only going to be 3. So government spending is going to have a better impact on AD than cutting taxes. Okay? And remember also that if you're increasing taxes, you have to decrease GDP and your tax multiplier will be negative, just like we did before. Okay? So here's your equation. Total change in GDP equals tax multiplier times initial change in taxes. Total change in GDP times tax multiplier times initial change in taxes.